others. I'm going to record this one, ha? Kumusta? Ayos pa naman kayo? I hope everyone's okay, ha? Baka nangyari sa mental health break, RNR, tapos kung saan-saan nakarating. Pagbalik, iba ang nadala. Okay, sige. So, I cannot open my camera first, ha? I have to use this later on. Sige, kung may naalala pa kayo, baka naman may nakalimutan na kayo. May naalala pa kayo sa pinag-aralan last time. What is our topic last time? Paki-open ako ng camera so I can record who are already in the meeting. Para later on, I will have no problem with the attendance. What's our topic last time? Okay lang ba ang microphone, ang audio ko?
Opo, ma'am.
Yes, ma'am.
What's our topic last time? If you still remember.
Yung Caballero's principle po.
Okay, so we have discussed the Caballero's principle. And it is all about determination of what? Determination of, alam nyo kung ano? Determination of, kita mo, wala talaga nagawa yung mental health break, lalong nakalimot kayo. Tapos lalo kayong nawala ng enerhiya. Anong nangyari sa inyo? Parang lalo kayong hindi nagpa-participate, Wait, sige. So, can you see what I am showing in my screen?
Yes, yes.
po.
Sige, so our topic for today is similar to the Caballero's, the continuation of Caballero's principle. But first, let us have some review. So our topic is all about pyramid. And the last time, we have discussed the different theorems and we solved problems involving the Caballero's principle. This time, we are going to talk about pyramid. So when we are talking about pyramid, we are discussing more of a polyhedron. So when we say polyhedron, it is one which include 3 or more triangular faces. So say for example, we have the lateral faces, which is triangular. So if you have this kind of figure, and we got several lateral faces. So this is one lateral face, then another lateral face, and another lateral face. So we have how many? Sorry for that. Let me erase that one. Let me just so we have a this kind of figure. Let's say this is the kind of figure that we have. So we have 1, 2, 3, 4 lateral faces here. I'm having hard time with my whiteboard, with my pen here. Okay, so this is an example of a pyramid. So if you have a polyhedron with triangular faces, so meaning one of the lateral faces is a triangle, this is called the lateral face. So they are meeting at a common point which we call as the vertex or the apex. So when we talk about pyramid, we have a vertex. So this is what you call as the vertex or the apex. So this is the point where the triangular faces will meet each other. So they are meeting at a common point, and one other face is called the base. So this is what you call as the base of the pyramid. So depending on the number of sides of the base, we are going to call the kind of pyramid that we have. Let's say, for example, we have a triangular pyramid. So when we talk about triangular pyramid, the base is a triangle. But when we talk about quadrangular pyramid, we are talking about four sides base and four-sided base. And if we are going to talk about pentagonal pyramid, that means we have five sides for the base. So again, the type of the pyramid is dependent on the kind of base that you have. So if you have a triangular pyramid, that means we have three sides. Okay. So a triangular pyramid that has four faces, that means we have three lateral faces and one base. That is what you call as a triangular pyramid, and you call it tetrahedron. Okay. So other properties that we have for pyramid is the altitude. So if we are going to talk about altitude, that is the perpendicular distance from the vertex to the plane. If you are going to take a look at this figure, from the vertex down to the base of the pyramid, and you've got a perpendicular line, that is what you call as the height of the pyramid. So that is the height of the pyramid. That is the perpendicular distance from the vertex down to the base of the pyramid. So that is what you call as the altitude. Any pyramid can be subdivided into tetrahedron. So if you are going to take a look at that, they have a common altitude which is equal to the altitude of the given pyramid. You can do the subdivision by subdividing the base polygon into triangle, and then you're going to pass the planes through the lines of the base and the vertex of the pyramid. So let me draw the figure. So let's say, for example, you have we have a pyramid here. Okay, let's go back to the pyramid. If we have the pyramid here, and we are going to cut a section. Let me cut a section here. Okay, you can cut a section. That means you will create two pyramids here. One at the top and one at the bottom. So any pyramid can be subdivided into section also. Parallel to the base are to each other as the square of the distances from the vertex. So meaning, if we cut a section here, the upper portion is parallel to the lower portion. And that means take note of the sections of the pyramid parallel to the base. As to the square of the distances of the vertex, they are to each other, equal. So two pyramids with the same equal bases and equal altitude are also considered as equal. So going back into this kind of pyramid that we have, you would notice that we have other properties. Like for example, we have the lateral area. If you are going to go back on our previous discussion, the very first topic that we did was to determine the lateral area of different prism. So the same is true with pyramid. When you talk about lateral area, that is equal to the sum of the areas of the lateral faces. Going back into this kind of pyramid that we drawn here, how many sides do we have here? How many sides? For this kind of pyramid, how many sides do we have here? Anyone? How many sides? You've got 1, 2, 3, 4 sides. So how many lateral faces do we have here? How many lateral faces do we have? If we have 4 sides, how many lateral faces do we have? Anyone? Uy, may kausap pa ba ako? How many lateral faces do we have?
4 po.
Okay, very good. We have 4 lateral faces. Diba? And if you are going to take a look at the plan from the top, looking at the top of the pyramid, you would notice these are the lateral faces. You've got 1, 2, 3, 4 lateral faces. And those are triangular faces. Can you view, can you figure out, okay, what I mean? So this is viewed from the top. So this is the apex or the vertex. This top is meeting at a common point, and that is what you call as the vertex or the apex. And because we have 4 sides for the base, that means we also have 4 lateral faces. So if you would like to determine the lateral area, that is simply equal to the sum of the areas of the lateral faces. While the total area will be the sum of the lateral area plus the area of the base. So which is basically the same as what we have discussed previously. If you would like to determine the total area, all you have to do is to get the sum of the lateral area and the area of the base. That would give you the total total area. Then talking about lateral faces, we also have lateral edges. So when you say lateral edges, we are talking about regular pyramid. And in regular pyramid, okay, so the lateral edges in regular pyramid are equal. Can you still hear me?
Yes po.
Yes po, ma'am.
So we have the lateral edges, which are equal. And then we have the lateral faces for regular pyramid. These are enclosed by equal isosceles triangle. What do you mean by isosceles? What do you mean by isosceles triangle? Anyone? What do we mean by isosceles triangle?
2 sides are equal po.
Okay, very good. So when we talk about isosceles triangle, 2 sides are equal. So if we are going to go back in this figure wherein you have the lateral faces shown here, this is equal to this side. And this is equal to this side also. And this is equal to this side also. So that means we have equal sides of the isosceles. But that doesn't mean that this side
of the base is equal to the other side. So we only have isosceles triangle. So those are the equal sides. And definitely that is also the lateral edges. Okay, so any regular pyramid, all the altitudes of the lateral faces have a slant height which are equal to each other. So going back into the lateral faces that we have here, okay, if you would notice here, if this is the height of the pyramid, that is a perpendicular distance, you would notice that this distance, the distance from here, from the apex down to the side, okay, is different from this distance, which is the height. This is what you call as you call this as your slant height. Okay, so that is slant height. That is different from the altitude. So if you are going to separate that figure, this is the slant height. Okay, that is the slant height. That is also the slant height. While this one, this is the altitude h. Okay, so this is the slant height and this is the altitude h. Okay, so that is those are two different things. Okay, when we talk about pyramid, this is the apex. The perpendicular distance from the apex down to the base is the altitude, while this distance from here down to the base is the slant height. Can you figure it out? Okay.
Yes po.
So those are the properties of the pyramid that we have to consider. And take note, again, any regular pyramid, all the altitudes of the lateral faces are equal to each other. Okay, so now let's go to one of the theorems that we have for pyramid. So the first theorem that we are going to use is that the lateral area of a regular pyramid is equal to 1/2 of the product of the perimeter of the base and the slant height. Take note of that. The lateral area of a regular pyramid is equal to 1/2 the product of the perimeter of the base and the slant height. So again, if you are going to go back into our figure, the last time, this will be the perimeter. Okay, the perimeter will be from this point up to this point, from this point up to this point, from this point up to this point, and from this point up to this point will be the perimeter. Okay, so according to theorem number 1, it's simply equal to 1/2 the lateral area is simply equals to 1/2 of the product of the perimeter of the base. Okay, so perimeter of the base multiplied by the slant height. Multiplied by the slant height. Okay, so you have this as the formula for the lateral areas of the pyramid. Okay, so let us try solving one problem here. We are going to find the total area of a regular pyramid, which is 16 centimeter high, with a rhombus base. Okay, the base is a rhombus. The side is 24 centimeter, and it has a 10 centimeter in one diagonal. Now, can you view what I am writing on my figure, on my screen? Not yet. Let me end my presentation. Okay. Can you view my camera?
Yes, ma'am.
So according to the problem, we are going to find the total area of a regular pyramid. Let's go back to the problem. According to the problem, we are going to find the total area of a regular pyramid with rhombus as a side, 24 centimeter and 10 centimeter in one diagonal. So what do you mean by rhombus? How do you draw a rhombus? Anyone who knows what a rhombus is?
Para po siyang dalawang parallel lines. Dalawang set ng parallel lines.
Okay. So that is also similar to, almost similar to a what? Almost similar to a square. Okay. So rhombus is the same or almost similar to a parallelogram. The only difference is that all sides are equal. So tama si Charles doon. Para silang sa parallel sides. But the only difference is that pwede nyo nang i-off yung inyong camera. So you can view my presentation on a larger scale. Okay, sige, you can off your camera. Carl, Princess, can you off your camera? So we can have a larger view of the figure. Okay, there you go. Tama si Charles doon kanina. So you have here parallel lines. Okay, the only difference is that in parallelogram, only two pair of sides are equal. But in the case of rhombus, all sides are equal. Okay, so if you are going to draw a pyramid, that means we have a vertex. And the vertex is the point where all the lateral faces are meeting. So that is the common point. So if you are going to draw a pyramid, kindly bear with my figure here with my drawing. I am using a freehand drawing here. So this is the pyramid that we are talking about. And what we have here, the base is a rhombus. So let me just, so you can have a better view of this. Okay. So the base is a rhombus. And according to the problem, the regular pyramid has a height of 16 centimeter. So the height of the pyramid, if we are going to draw the height of the pyramid, that is from the vertex down to the base. I am not drawing not to scale. I am drawing not to scale, huh? So this is what you call as the height, that is 16 centimeter according to the problem. And one of the sides of the base is 24 centimeter. So that means this is 24 centimeter. And because the base is a rhombus, okay, we have a rhombus base. Later on, we are going to draw the base. Let's isolate the base. Can you still see what I am writing on my board here?
Yes po, ma'am.
Okay, so the base is rhombus and one of the sides, diagonal, I mean, is 10. So if we draw the diagonals, these are the two diagonals of the rhombus. And according to the problem, one of the diagonals is 10. So let us say this is 5 plus 5. Okay, so that is the base. And this one is our three-dimensional figure photo for the pyramid. So if you are going to notice, if this is 24 centimeter, this side is what? This is half of the 24 centimeter. So that means this is 12 centimeter. So this is 12 plus 12, that is 24 centimeter. So if you are going to take a look at this figure, okay, we can isolate this figure. Take note of this. We can isolate this figure and you would notice we can create a right triangle here. So again, we are going to go back to our basic technique. What we have to do is to look for a right triangle. Okay? Yun yung tinuro ko sa inyong technique data, di ba? So you have to look for a right triangle always. You would notice that if we isolate that particular figure, we can create a right triangle. Okay. So this is our right triangle. And you would notice, what is this height? This is 16. What is this side? This is 12. Okay, so this is 16 centimeter, this is 12 centimeter. And this one, how do you call this one? What's the value of this? If this is 16, this is 12, how do you call this one?
Slant height.
Okay, very good. So that is the slant height. That's the difference between the altitude and the slant height. This is the slant height, while this one is the altitude. So if you are given a problem and you're given the altitude is taken from the vertex down to the base in perpendicular distance. But the slant height is a different thing. So the slant height is taken from the vertex down to the base, but take note, it is not perpendicular with the base. Okay, in this particular case. Okay, so you have the slant height. It has a certain degree with degree angle with the base. Okay. So the question here is, since we are given all these figures and all this data, what we are going to determine is the what? The question is total area. So we are going to find, can you still view what I am writing?
Yes po.
Okay. So we are going to find the total area. And remember that our formula for total area is what? Total area is equals to the lateral area of the sides of the pyramid plus the area of the base. Okay, so the same is true with what we have discussed previously. to determine the total area, that is simply equals to the lateral area plus the area of the base. So the question here now is, what is the lateral area and what is the area of the base in order for us to solve for the total area? So let us solve first for the slant height, okay? Let us solve first for the slant height. Let's say this is point P. Let's say this is point O. And let's say this is point A. Okay. If that is the case, then this triangle POA, we can determine the slant height, which is basically the distance or the line segment AP. Okay. So line segment AP is the slant height. So how do we determine the slant height? What will be the formula for the slant height?
Ma'am, Pythagorean theorem po.
Okay, very good. So we are going to make use of the Pythagorean theorem. So how do we determine the slant height using the Pythagorean theorem? How do you determine the slant height using the Pythagorean theorem? We have slant height squared is equals to 16 squared plus 12 squared. Can you still follow?
Yes po.
So the slant height is equals to the square root of 16 squared plus 12 squared. Will you please calculate for the slant height?
Ma'am, 20 po.
We have 20 centimeter. Okay. So next, what do you think will be our first move? A second move. So after determining the slant height, can we now determine the perimeter of the base? Can we now determine the perimeter of the base? How do we determine the perimeter of the base? You've got 1, 2, 3, 4. How many? How many sides do we have for the perimeter of the base? We have how many sides? Anyone? How many sides do we have for the base?
4 po.
Apat. Okay, so in order for us to determine the perimeter, we're just going to add all the sides of the base. So what will be the perimeter of the base? How many sides do we have? 4. Multiply it by how much? Multiply it by how many?
24 po.
Very good. 24. 24 centimeters. So the perimeter of the base is equals to 96 centimeter. According to theorem number 1, the lateral area is equals to what? The lateral area is equals to
Sum of the areas of the lateral faces po.
lateral area is equals to 1/2 times the product of the perimeter of the base multiplied by the slant height. That is according to our theorem that we discussed. The lateral area is equals to 1/2 times perimeter of the base times slant height. So that means lateral area is equals to 1/2. Perimeter of the base is 96. The slant height is 20. So what's the lateral area? Sorry. What is the lateral area?
Ma'am,
Kindly
960 po.
960, the unit is,
Centimeters.
what is the unit? 900,
Centimeters squared po.
okay, square centimeter. So we have 960 square centimeter. That is the lateral area. But take note, the question is total area. So we have yet to determine the area of the base. So how do we determine the area of the base? Take note that we have a rhombus base. So if you are going to determine the area of the base, okay, so the area of the base is simply equals to, how do you determine the area of the base? Remember, we have x here, we have 5, 5. So that is according to the problem. One of the diagonals is 10. So we don't know this diagonal, the second diagonal. Let's say that is x, and let's say this is also x. And if you are going to notice, isolating the right triangle again. So again, the technique is to find a right triangle. Okay, if you are going to isolate this right triangle, this is 5. This one is x. What about this value? What is the value of the third side? What is the value of this third side?
Ma'am, 24 po.
Okay, so that is 24 centimeter. So this is 5, this is x, so this is 24 centimeter. So how do you determine the area of the base? We need to compute for x first, so we can determine the area of the base. Here. Okay. So how do you determine this value of x? How do you determine the value of x? Again, by, how do you determine the value of x? Using this right triangle? Again, by Pythagorean.
Pythagorean theorem.
Okay, Pythagorean theorem. 24 squared is equals to 5 squared plus x squared. And if you would like to determine the value of x, that is simply equals to the square root of 24 squared minus 5 squared. So that we will have the value for x is equals to, kindly calculate if you have the same value as I have computed, 23.473 centimeter. And the other diagonal will be 2x. The other diagonal is 2x, and that is equals to 46.95 centimeter, or if you are going to round it off, that is roughly equivalent to 47 centimeter. So now, if you are going to determine the area of the rhombus base, that is simply equals to 1/2 times d sub 1 times d sub 2. So that is the formula for a rhombus. All you have to do is to determine the diagonals. The area of the rhombus is 1/2 d sub 1 times d sub 2. So that is why you have 1/2 for the area of the base, that is equivalent to 1/2. D sub 1 is 10. D sub 2 is 47. And that is roughly equivalent to, alan?
235 po.
235 square centimeter. And that means if you would like to determine the total area, you just add up lateral area plus the area of the base. So the total area is equals to lateral area is 960 square centimeter plus 235 square centimeter, and that would mean the total area is equals to, you please calculate for this one.
1,195 centimeters square po.
1,000, okay, so 1,195 square centimeter. And this will be our answer. That is the total area. Any question? Later on, we are going to discuss some more problem, in which we are going to find the lateral the basis and the area by simply making use of the triangle. Okay, so all you have to do is to determine first the area of the lateral faces. So you would notice if this is the lateral face, once you have the slant height, okay, actually the formula for this lateral area is taken from the area of the slant height, and then you multiply it by the number of number of sides. Okay. Sige, how do we do that? Do you have any question? Meron kayong question? Okay. Let me just explain how we arrive with the formula of the theorem for the lateral area. Take note, the lateral area is equals to 1/2 times perimeter of the base times the slant height, diba? Okay? So that was a given formula already. So you can derive, kung medyo nakalimutan nyo, pwede naman kayong mag-proceed into determination of the lateral area by using the basic geometry. Okay? If you are going to take a look at this, diba? This is a triangle. So let's say this is point B, this is point C, that is point O. If you are going to isolate the triangle, okay, this is point P, this is point B, and this is point C. And take note, this is point A. The distance from A to P is what you call as the slant height. From A to P is your slant height. And according to our computation, for the slant height, the value of the slant height is 20 centimeter. Okay, you have the value for the slant height is 20 centimeter. While the value for this line segment, from line segment BC, which is equals to this one, which is equals also to 24 centimeter, diba? If this is 24, because we have a rhombus here, this is also 24, this is also 24, and this is also 24. Okay, so you have the line segment BC, this is 24 centimeter. Okay, and if you are going to take a look at this, you have the formula for the area of triangle. So that means if you are looking for the area of triangle PBC, that is simply equals to 1/2. Area is 1/2 base times height. So our height here is the slant height. So you have 1/2, you have 24, and then slant height is 20. Will you please calculate for this?
240 po.
240 square centimeter. So you can use that as our, is that 240? Okay, so 1/2 times 24 times 20. So you have 240. You can use that to determine the lateral area. Okay, the total lateral area is simply, how many sides do we have? How many lateral faces do we have?
4.
We
4.
have 4, di ba? We have 4. So you multiply 4 by the area of one lateral face, which is 240 square centimeter. And that is also the same as the value that we get. That is also the same as 960. That is the same as 960. Okay? So that's why you have here the lateral area 960. Can you figure it out?
Yes po, ma'am.
Okay. So that's basically the same principle of the theorem that was presented. Okay. So all you have to do is to get the area, of one lateral face, then you multiply it by the number of faces. So you would have the total lateral area for the pyramid. Any question? Any question?
Ma'am, dun po sa area of the base, saan po nakuha yung 2x?
Itong 2x, ito yon, yung diagonal, yung second diagonal. X plus x.
Okay po.
Ang x lang natin ay ito. So yung diagonal, yung second diagonal, that is 2x.
Yung pong 5, paano po nakuha yung 5?
Etong 5, given dun sa problem. Balikan natin yung problem. According to the problem, 10 centimeter in one diagonal. Okay na? Kaya yung kalahati ng 10, yung 5. Kaya nagkaroon tayo ng 5 na value.
Yes po.
Okay na.
Ay ma'am, hindi po ba pwedeng i-substitute yung 10 dun sa 2x?
Hindi, magkaiba siya. Magkaiba
Okay po.
yung value nito. Hindi magkaparehas ang diagonals nun.
Okay po.
Any more? Hindi magiging magkaparehas yung diagonal kasi yung side niya, iba itong side na ito. Okay. Any other clarification? Any more clarification? Kahit rhombus yun ang kaibahan pagka rhombus at saka square. Kasi pag square, di ba pag square, ganyan, parehas lang ito at saka ito. Okay? Itong side na to, itong diagonal na to hanggang dito is the same as this one hanggang doon. Pero pag rhombus, dahil nga siya ay naka-inclined yung one of the parallel side, one of the pair of the sides is inclined. Okay, so iba itong diagonal dito kesa dito sa diagonal na yan. So this is D sub 2 while this one is D sub 1. So magkaiba yung value ng diagonal. Okay, that's why we have to determine the value of x. Anything more? Any other clarification?
Ay ma'am, dun po sa pagkuha ng value ng x, bakit po ma'am subtraction yung ginamit?
By Pythagorean theorem, if you are going to take a look at this figure, this is the hypotenuse. And the sides are 5 and x. So if you are going to set this to be C, let's say this is A and this is B, Based on Pythagorean theorem, we have c squared is equals to a squared plus b squared. But since we are looking for the value of a, okay, we are looking for the value of a, we are going to transpose to the other side of the equation. That would become c squared minus, pag transpose natin doon sa kabilang side yung b squared, that is equals to a squared. So that is why we have yung 24 natin minus yung 5 squared is equals to x squared. So that is 24 squared minus 5 squared is equals to x squared. Kaya 24 minus 5 squared is equals to x squared. Kaya minus ito. Is that clear?
Yes po. Okay po.
Okay. Anything more? Any further clarification? Sige, kung wala na kayong question, you kindly open your camera so I can record again your attendance. Andrian is present. Is Andrian present here?
Present po.
Okay, Angelica. What about Angelica? Okay, Camila. Camila.
Present.
Okay, Charles. You still there, Charles?
Charles, ano po?
Andrew. Marami ba kayong Charles dito?
Meron pong Aquino.
Ah, okay. Sige. Dorothy.
Present po.
MJ.
Present po.
Faith. Aubrey. Dalawa pala ang Faith dito.
Present po.
Faith. Clemente. The single Faith.
Present po.
Okay. Sure kayo wala kayong question? Naintindihan nyo? O hindi nyo naintindihan? Dalawang bagay lang yun. Huwag mahihiyang magtanong kung hindi naintindihan. Hera. O baka nahihiya lang, huwag kayong, okay, huwag kayong mahihiyang magtanong. Isaiah,
Present po.
Jake. Wala si Jake.
Present po, ma'am.
Ah, okay. Jerome.
Present po.
John, Nicole. John Nicole.
ma'am.
Okay, John, okay. John Ray.
Present po, ma'am.
John Robert.
Present po, ma'am.
Okay. Joy Gian.
Present po, ma'am.
Juliana.
Present po, ma'am.
Carl Bryan.
Dito po.
Carl Kinney. King. Wala si Carl Kinney. Mr. Bonita. Hindi ko ikaw marinig at hindi ko rin makita ang video mo. King Charles. Wala si King Charles. Kasama na ni Camila si King Charles. Laika. Nawawala si King Charles. Okay. Mariel.
Present po.
May.
Present po.
Michelle.
Present po.
Micaela.
Present po.
Natasha.
Present po.
Neil.
Present po, ma'am.
Okay. Piolo.
Present po.
Princess Angelica. Rashid, wala si Princess? Oo, nag-o-open ka ng camera, Princess, pero mukhang hindi ko ikaw marinig. Rashid,
Present po.
Samantha,
Present po.
Raymond,
Present po, ma'am.
Sean,
Present po.
Shaira,
Present po.
Sheeter, wala. Trisha,
Ma'am, present po.
present. Okay, sige. Sino yung hindi ko natawag? Wala na?
Ma'am, ako po.
Sino po?
Sabi po.
Si? Falcon. Okay, sige. Okay, kung wala na kayong tanong, sure kayo naintindihan nyo? Clear sa inyo? So, next meeting, we are going to discuss because our examination is set on the next week. Midterm exam na next week. So, we are going to fast track our discussion to cope with the topics. Okay? Sige. Kasi nga nag-mental health break kayo, so kailangan nating mag-cope ngayon ng lesson kasi midterm exam na next week. Okay. So our exam next week will be computer, yung mga computations na, more of the computations. Sige. So wala na kayong tanong? Clear na sa inyo lahat? Shaira, you raising your hand, Shaira?
About po sa niyo, LMS, ma'am. Nakikita niyo po ba yung comment po doon?
Yes. I will take a look at the Neo LMS again. Okay. So far, hindi pa ulit ako bumabalik doon sa Neo LMS, Shaira.
Thank you po.
Okay. Any more concern? Okay. Wala na talaga. Si Charles, mukhang may klase ng kasunod. Dahil ako may klase na rin kasunod, shall see you next meeting. You kindly stay safe and stay healthy, everyone. See you next meeting. Bye-bye.
Thank you po, ma'am. Happy Teacher's Day
Thank
po.
you po.
Thank you
ma'am.
po.
Okay. Thank you very much.
Happy Teacher's Day po.
Thank you very much. Magandang umaga sa inyong lahat ulit.